I think now with generative AI and foundation models, AI is really turning into platform technology. And from an IBM perspective, that means it has to be built in the open because a platform has to cater to a variety of needs, run in multiple environments, enable developers to build interesting things. So we've been committed to open.
Hi, welcome to AI Confidential. This is the podcast about AI and how to benefit from it responsibly. I'm Aaron Fulkerson, the CEO of Opaque.
And I'm Mark Hinkle, the founder and publisher of the Artificially Intelligent Enterprise. Today, we're excited to share a conversation we had at AllThingsOpen.ai conference in Durham in March.
Yeah, the conference that you organized with your team and Todd from the All Things Open conference series was really excellent. And you're now calling it All Things AI, right, Mark?
That's correct.
Yeah, I like that name. It was an outstanding event at a beautiful venue in Durham, North Carolina. I was grateful that you included me as a speaker. The attendance was, I know it broke all of your expectations, and it certainly, the quality of attendee exceeded my expectations. But above all else, I was really excited that we had an opportunity to sit down with Sriram Raghavan, the vice president of IBM Research AI. This is the gentleman who leads all of the AI research at IBM. And we were excited to speak with him because he's doing enterprise AI research. This is really effective, practical research for what the enterprise needs. So we talked about what innovation he sees coming down the pipeline for enterprise AI, why IBM is focusing on small language models while all the hype seems to be around large language models, and how IBM is approaching responsible AI.
Yeah, I think what he's doing is really important. He works with, him and his team work with Arvind, their CEO of IBM, directly every week. And that's a top priority for them as AI. So getting some of his time for us to speak to him was really fortunate. And, I thought it was a great conversation. He's really an engaging, smart, approachable tech leader. A lot of times you don't have all of those wrapped up into one. So I think it was a great conversation.
Yeah, and I think their strategy is really sound and valuable for the enterprise. It's very practical, and it aligns directly with what I'm hearing from our customers, their demands are, which is increasingly they want specialized models that allow them to use it with their data.
What we'll see is we're going to see a mixture of models that everyone uses. And without a doubt, any decent size enterprise, I'm a single person company, and I'm planning on using a IBM Granite model with my data internally because that's important for me to maintain my edge. And then I'll route those inquiries to either, my internal, what I call enterprise GPT, or I'll route them to OpenAI when I don't have a security concern, or, maybe someone else will come up. Gemini has actually become a very capable model with their last 2.5 release. So who knows how this horse race will end.
Well, you just jumped right into our next regular installment of AI in Context, which is our regular update on what AI developments we're most excited about right now. From my position, it's what we discussed with Sriram, because it's perfectly aligned with what the enterprise is expecting to do with agentic workflows. They're looking for more cost-effective and efficient ways with small language models that are more specialized around specific use cases that they can use in conjunction with their own proprietary data, which is often very sensitive and even confidential.
I would also make the point where you're 100% right on that. But the other thing that I thought was interesting when we talked to Sriram was there's a power concern. And a lot of times we're like revving up an 18-wheeler to haul a pencil across the parking lot. I mean, that's when you use a large language model, you're just burning up a lot of GPUs. And these small language models are perfectly capable of parsing data, creating code, doing a lot of these tasks. It's a matter of don't use a cannon to kill a mosquito, I guess is the old Chinese proverb. But that's another part that when we see all this headlines about power and data center needs that we don't think about. So you're right, 100% small language models using it with your own data, but it's also a matter of power consumption.
Yes. And we're also seeing mixtures of expert multi-agent workflows being even more effective when you're using specialized small language models around specific use cases. So there's the mixture of experts that are getting really exceptional outcomes. And then there's also something we've been talking about, which is, well, if you have sensitive or confidential data, you don't want that to leave your environment. So being able to host these, being able to use these on the edge, that's something that's really important. And I know you were talking about some AI in context around data in some papers that you read recently. Mark, tell us about that.
Yeah, so I was looking at, I think Accenture, Deloitte, McKinsey have all put out these papers recently about where we are with, pilots. Accenture did an analysis of 2,000 client projects and said most are stuck in pilot purgatory. And then they also pointed out that one of the big growing concerns or barriers to developing and deploying Gen AI was actually worries about complying with regulations and difficulty managing risks were their top two. Everything else seems to be like declining as far as implementation challenges and lack of talent. They're building those muscles, but it's really, how is this going to be regulated and will they be in compliance and what their risk is? Because as we've seen with various different, failures, there is a lot of risk when you start automating with AI.
The head of Accenture's global data practice, Teresa Tung, is on the first season of the AI Confidential podcast. Her and I spoke about this. It's a great episode. The paper that Accenture published where they talk about, they don't specifically call it pilot purgatory, but that's the net of it. She since is updated with, they have done over 2,000 implementations of generative AI. We're seeing the AI maturity curve break into 3, maybe even 4 waves. The first one being sandbox, which is experimentation or pilot. The second one being plateau, which is they get into production, but it's with non-sensitive data. So the value is maybe increased productivity gains, but not differentiating value. And then the third wave of maturity is the AI powerhouse. And that's when companies are adopting AI with their most sensitive and confidential data. That's where you create real differentiated value. At the All Things AI, you did a great job of getting the audience engaged, and you were asking them which wave everybody fell in. I was surprised how many were in production. It was pretty much everybody there was in production with Gen AI use cases.
I was surprised by that as well. I would love to have dug into that, but it's hard to dig into a crowd of 1,000 people. What's going on? And some folks were telling me what they were doing, like LabCorp, the head of their AI program built his first ML model in 2009. Adam Sullivan. I thought that was interesting. I mean, he was machine learning before AI was cool, and now they've had this long ramp up. But then there were quite a few other ones. GSK was doing it for drug safety at a significant scale and with significant benefits. Overall, it's fascinating to me to see just the dichotomy between some folks are suffering from paralysis through analysis and other people are just diving in headfirst, like you see Moderna being the flagship OpenAI case study.
Yeah, I spoke with more than 100 people between my conversations between sessions, and then also we had an AI executive event the night after. And consistently, when I dug into it in those conversations and in that 70-person executive salon event, it was wave 2. It was, hey, we're in production, but we can't use sensitive data. And you just highlighted in the Deloitte report, the McKinsey report, the Accenture report. I know you mentioned one before we were on air around the MIT report too. What was the MIT one that you mentioned?
It was on data. And so last year they did a bunch of, and this is the number one thing that I struggle explaining, and I think people in large organizations struggle with how they're going to tackle, and that's data integration or pipeline. So that pipeline that you feed your ongoing data, whether it's your sales data, or your CRM data, your logistics, your ERP data, into these models so that it's actionable through the model. And then right after data integration, the number one concern was data governance or security concerns, which I know is near and dear to your heart.
Yeah, it's exactly what Opaque is focused on solving for companies so that they can responsibly adopt AI. So the AI in context, I think small language models, hey, IBM doesn't have to be leading the world in the largest large language model to be an innovative leader in AI. They're going where the enterprise demand is, which is with small language models. And then further, your recent research that you've synthesized from these analyst reports, I think is definitely what we're seeing too, to put AI in context.
Yeah, and just if I go back to that Accenture report I was reading, it's called "Making Reinvention Real with Gen AI." There's two other points around that I thought were interesting. One on the data point is the folks that are 2.9% more likely to be successful also have a comprehensive data strategy to support their Gen AI efforts. The thing that I feel like the blind spot for most folks is just how important reinventing talent is and getting them upskilled. So, at the conference, the first day of our conference, we trained over 750 people live on everything from sort of knowledge worker productivity to retrieval augmented generation to building large language models with IBM. So I think that the overarching theme that I'm seeing is they're willing to spend money on the technology, but there's really and I don't think that anyone is unwilling to spend money on the upskilling, but I don't think there's a clear path for upskilling. That's why I spend my time helping people understand it, because I think that's the gotcha along with the data integration.
Great. Let's get into our conversation with Sriram. Welcome to AI Confidential. I'm joined with Mark Hinkle, my occasional co-host. We're at the AllThingsOpen.ai conference in Durham, North Carolina. I had to remember which city we're in because I'm between Chapel Hill, Raleigh, and Durham. In Durham, North Carolina, that Mark Hinkle's organizing. And we're joined by one of the keynote speakers, Sriram Raghavan, the Vice President of IBM Research AI, who's doing some of the most groundbreaking research in AI, specifically for the enterprise. And we're really excited for him to share his strategy and some recent announcements he's made. Why don't you kick off by introducing yourself?
Yes, thank you, Aaron and Mark. Pleasure to be here. It's been a wonderful day this morning. I had a chance to be at the conference in keynote. My official title is Vice President IBM Research AI. That basically means that I get to lead a global team of research scientists and engineers across IBM's research organization across the globe. And I'm responsible for both advancing the field of AI, fundamental evolution, as well as working with IBM's business units delivering technology to our software and consulting offerings. So fun job. I get to travel a lot, visit our global labs, and I'm based out of New York, but I get to travel a lot to visit our teams all over the globe.
Well, thank you so much for joining us. I know that, Mark, you invited Sriram to keynote. Tell us a little about the event.
So we've been thinking about this for a long time. Raleigh-Durham has a huge tech population. I even believe it's North Carolina's IBM's biggest location for employees. And we typically do not have large tech events that are like you would in Silicon Valley. So we wanted to come up with a event that we could encourage learning around AI in the triangle. And Sriram and the IBM team were the first ones that signed on to help us do that. And in the last 2 days, yesterday we trained 800 people on how to use generative AI at both a technical level and a desktop level. And we also had over 1,000 people for today's event. But what really made IBM such a good partner for this was their open innovation. I mean, we met one of Sriram's mandates is open innovation at IBM. And so he was the perfect choice for the keynote because I think you have some exciting news today.
Indeed. Yeah. So maybe I'll share a little bit of what we announced.
And I mean, you did news last week around APC, and then you did a bunch of announcements today. Yes. So give us the whole raft of all the goodies that you announced.
Yeah. So look, I think maybe I'll pick off what Mark started with. We've been very clear from an IBM perspective ever since sort of this most recent era of Gen AI. We've been doing AI for a long time, right? From chess playing machines to Jeopardy to the most recent era. It was very clear to us that this era of AI is going to be built in the open with open innovation, and it's going to be a real platform technology. For the long time, AI had been sort of this method game. Do you have a new machine learning technique? I have a new machine learning technique. I think now with generative AI and foundation models, AI is really turning into platform technology. And from an IBM perspective, that means it has to be built in the open because a platform has to cater to a variety of needs, run in multiple environments, enable developers to build interesting things. So we've been committed to open. And we started off the open journey in IBM first from a platform lens. So even when we announced our watsonx platform in 2023 at our Think conference, we announced it on top of an open stack, PyTorch, VLLM, based on Kubernetes, all of that. But over the last 12 to 18 months, we have doubled down on open even from a model and agents perspective. And so today, what I had the privilege to announce at Mark's conference was 3 projects that we are contributing to the Linux Foundation. These are projects that are already out in the open, but we certainly want to now bring a broader population together. And the 3 projects actually, we think, address important elements around the model, but that are going to be important for AI. There's a lot of conversation around models, and I'm sure Mark and Aaron, we will talk about small models, big models. But beyond models, to build useful AI, we first deal with a data problem. How do I prepare data to make it useful for models? And a lot of this is unstructured data. So we announced 2 projects called Data Prep Kit and Docling. Data Prep Kit is about pipelines for manipulating unstructured data, preparing it. Whether you are fine-tuning a model, whether you are doing RAG applications, whether you're trying to train a model, whatever you want to do, preparing data. Data Prep Kit lets you build those unstructured data pipelines, build on a laptop, scale it with Spark and Ray in the cloud, as you need to. And Docling addresses that complex task of making sense of complex formatted documents that are primarily created for a human consumption. A complex PDF file with charts and figures, or an Excel or a PowerPoint, they're not designed for an LLM. They're designed for humans to see. How do you turn those documents into text that then the LLM can make sense of? So that's what Docling does. So we are contributing those 2 to the Linux Foundation, and we think they are ripe for amazing community innovation. And then the third piece is, okay, we have models, we have data. Okay, what is the new application archetype that's emerging? And that's agents. And so we're also contributing to the Linux Foundation, Bee, named after the Bee in IBM, icon is the actual Bee. And it's actually a platform that specifically does 2 things. It is a framework for building agents called BeeAI framework. But more importantly, we recognize that there's a plethora of frameworks to build agents. Rightfully so, because we are early in the agent journey. Lots of people have opinions around ways to build agents. So we think it is important to have a way to orchestrate and discover agents, however they may be built. So the other part of Bee is a platform for discovering and orchestrating agents. And that goes back to something we announced last week at AI Dev, which is a protocol called ACP. Actually, we are extending the model context protocol that Anthropic released to now add agents as first-class citizens and then have agents communicate with each other. So lots of exciting stuff. We can certainly talk more, but we had the pleasure of announcing at Mars conference that all of 3 projects are going to be contributed to the Linux Foundation.
And actually, I think that's MCP, or Model Context Protocol, is everywhere the last couple weeks. Can you expand on what that actually means? Because I think it is it an open standard yet?
So it is. It's out in the open. It's out in the open. I view it this way. I think MCP is trying to do the following, which I think is why I think it's getting a lot of attention. If you're going to build agents with models, we need a way for other services to be used by that agent powered by the model, which means that we need a standard way in which you can make those other services, whether they are data services, whether they are functions, whether they are an ISV or an entire piece of software, make them advertise what you can do in a standard way, so that then the model will know, when I know I need to send an email, when I know I need to post a message, okay, I have a standard way to do that. And I think it's trying to build that bridge between models and agents powered by models and all of the other services that make up the software ecosystem. So one simple way to think about it is, the way a model knows to do something is if it can show up in the context. Okay, how do you make that context available to the model when the context may include your service, your function, my piece of software, my data? That's what MCP is looking to address. What we are doing with ACP is to say, great, providing context to models is fantastic, but now since an agent is a new application archetype, let's make agents first-class citizens, and then talk about how agents advertise themselves to other agents as an extension of MCP, so you start to get compositionality. That's sort of, I think, the world that we're headed into.
So your emphasis on open is terrific. I went to Chapel Hill for my undergraduate degree in computer science, where Fred Brooks was the founder of the program.
Right.
He was also the creator of the IBM 360 project, which standardized and opened PC hardware, which made the personal computer possible.
Right.
And then every major trend in technology has been created on a foundation of open source or openness around open standards or open source, from personal computing to the internet to cloud to mobile to here we are again, where the way to innovate and be differentiated in this new world of AI is through openness. And there's a lot of people who talk about open models, but IBM's takes a very different approach from what some people consider open models. And Mark, why don't you talk a little bit? I know that you were talking about this at the event a little bit, and we'll ask Sriram to clarify more.
Yeah, so I've spent 25 years working on open source, and the thing that's been very interesting is that definition that made the internet great had a certain set of rules that really meant that you could take this code and you could replicate that. But now we're in this era of AI where open source and the models does not make the same sense, because in the old days, it was like you could take the recipe and you could replicate the cookie, but or actually the bread, because if you have different equipment now, you can get the recipe, you can know what the code is. It can be under a legitimate open source license that's approved by the Open Source Initiative. You can understand what the parameters are. So we'll share the parameters for the model, the weights. And the third thing is you can have a data bill of materials, just like a software bill of materials, because it's impractical to distribute petabytes and petabytes of data. But if you have, just like if you're making pizza in New York, if you don't have the same water concentration, or in this case, the same GPU concentration, the same power fluctuations, it's a little different. So you gotta adhere to these things, knowing it'll be a little different. And not everyone who says they're open is really open. They don't provide the training bill of materials. So I know that Granite is open source, and I think it adheres to the Mark Hinkle definition of open source.
Sriram, walk through, Mark just outlined them, but summarize what those three are again, and why you're taking that approach.
No, absolutely. Look, I think we started, it was in 2024, we started with open sourcing our Granite models. And as Mark rightly pointed out, I think as a community, we're going to uncover what it truly means to build a full open ecosystem around models, right? But a few things were clear to us. As Mark said, there is no point us trying to mimic every piece of definition of open source software, because the act of creating a model, at least a base model, now requires enormous infrastructure and data. However, we certainly know that downstream from a base model creation, there's a lot of innovation that can be done in the open. So how do I provide an open source model that is transparent in how it was created, which means, to Mark's point on a bill of materials, being transparent about what data sets, in what mixture and ratios were they used to produce that. So that's number one. Second is for downstream usage, let's innovate in AI and algorithms. Let's not innovate in licenses. We've spent 20 years as an open source community creating wonderful, well-understood licenses that developers know. So we took from the very beginning, we're going to release it with an Apache 2 license. So data bill of materials and Apache 2 license. And then the third piece was, again, we're too early in the AI journey to have a completely prescriptive hardware architecture, right? And a software stack. It's evolving. So let's give choice. So we will release a family of models, Granite family, consistent interfaces, consistent prompt templates, but you will have the ability to have models that are 500 million, 1 billion, 2 billion, 3 billion, 8 billion parameters. We are stuck with less than 10 billion because we can do a lot with less than 10 billion parameters. That's maybe the other discussion we'll have. We're releasing a family of models because, to Mark's point, we want to again give developers choice with different access to hardware. If you have an M3 Mac, there are certain things you can do. If you have an M1 Mac, certain things. You have the luxury to procure a GPU cluster on a cloud, you can do different things. Developer choice. So those were the three principles. Well understood license, transparent bill of materials, choice in terms of picking and choosing what you want. And finally, I would say, not try and bake everything into every model, but sort of open up the Unix philosophy of fit for purpose models that then the developers can compose in interesting ways. So that's why we release a time series model. Very, very good at time series. Less than, it's like half, I think it's the biggest one is less than 1 billion parameters. It can run on a CPU. It does a fantastic job for time series data. You want to combine that with a model where you're processing some documents. We have a vision language model, 2 billion parameters. You want a full-blown LLM? Yes, we have the Granite 3.2 LLM that will do language and code, 100 programming languages, 16 natural language. That's 8 billion parameters. You want to experiment with just guardrail models? We have Granite Guardian. Very lightweight models that you can use even with other LLMs to secure the prompts going in and secure the output coming in. So I would say those are the 4 principles: transparency, standard licenses, developer choice, and the ability to mix and match fit for purpose models. And that's sort of driving our Granite strategy. We began that with code in 2024, code models. And now in early 2025, we are at Granite 3.2, which we released in February, with all of these models that I just talked to you about.
You've been leading the team with 4 principles you just stated.
Right.
Restate those 4 principles again.
So the 4 principles were a clean, well-understood license, so Apache 2, a transparent bill of materials on what went into the model. Here are the data sets and training percentages, parameters, everything we used to train the model. So that's clear to people. Third is developer choice, models of different sizes and capabilities, so that I'm not requiring that to do anything with my models, there's a minimum hardware spec. You can pick and choose small models, big models, tiny models. And then fourth is this broader idea of fit for purpose models that you can compose and stitch together. Time series models, embedding models, guardrail models, LLMs. Yes, we can certainly have our big LLM do all of this, but by also giving you individual models that do these things well, you can use Granite for embedding model, compose it with a Llama model to build your RAG application. You can use our time series model with something else to build an application. So those were the 4 principles that we go behind, and we think that that's also why we're excited by the open community. By giving them these consumable pieces to build around, we really think that the community will be able to build amazing applications. We certainly would love for them to use Granite and build cool things.
The Apache days, for the web server, there was a way to extend it through modules. Where do you think the innovation is going to happen around these smaller models or these ecosystems? Like that's how you win is you have a platform,
right,
and that platform is extensible in some way. Where do you think that we haven't seen today? Or I mean, it's so early. Like everything's an innovation,
of course,
but at 2 weeks, it's become old news. So where's the innovation going to be?
So look, I think we're going to see innovation actually many pieces, Mark. Let's start with the center object of attention, the models themselves. We're just scratching the surface on model innovation. We have seen in 2 years capabilities that we thought required trillion parameters, triple-digit billion parameter models, now we're seeing models we talked about, like less than a billion, like 2-3 billion parameters. So that's like one type of innovation. Where did that come from? That came from architecture, came from data quality, data selection. There is an entire set of innovation happening on what's called state space models, which are going to be much less expensive to inference. How are we going to mix and match these today's transformer models and state space models? So architecture is one axis of innovation. The second axis of innovation is going to be composition. We talked about agents a lot. We are certainly going to be living in a world where we're going to have multitude of agents working together to solve a problem. Even a single agent is probably going to use multiple models, because why do I need one model to be good at everything? If I can have, so we're going to have that. So then that's going to be innovation in what are the frameworks to compose? What are the protocols to standardize on? How do I make this portable, right? So that's going to be a second axis of innovation. A third axis of innovation, we have so many modalities of data that we still haven't really fully exploited. In the last couple of years, the two modalities of data that we have really done a lot with is language and code, right? Those have dominated. A little bit of vision, image, etc. But we talked about time series data, a ton of that out there. Manufacturing, in financial data, molecular data, Earth observation, geospatial satellite data. So think of how many other modalities of data exist out there that the community can help bring into models, use to adapt models and build interesting applications. So I view sort of innovation in maybe three buckets. There's the core, if you will, AI innovation, that's going to be model architectures, how to make them efficient, etc. Innovation in how you build applications around those models, that's agents, protocols, composition, multi-agent, multi-model, all of that second bucket. And I think the third bucket is just the application areas themselves. I think we are scratching the surface in terms of application areas because we are focused on the two modalities that have dominated model development right now. But I think every modality of data that we use today, all of them are ripe because we have a new way of representing the data into these models. And that's the third area that I'm really, really excited about. That's going to require domain experts in those. I wouldn't presume, honestly, to know how to bring geospatial data into neural networks. That's why we partner with NASA. So we build geospatial models with them. Think of how many such domains in which you're going to have experts come in. And that's why open is very exciting, because this is going to require experts from different industries and domains to work together. And an open fabric of innovation is how you progress the field.
So you've outlined three exceptional vectors for innovation. One, you called it core AI, which is around architecture, which has a direct impact on the cost and the accessibility of running these models.
Exactly.
Right? So that's why it's going to, as a result, going back to Mark's original question, how is it going to drive innovation in the ecosystem? There'll be innovation around the architecture that lowers the cost, increases the accessibility so that people can deploy more groundbreaking models much more easier because the cost is going to dramatically get lowered.
Right.
The second area is how you build these. This has a cost factor too and an accessibility factor too, because you've made a conscious decision to focus on small language models, probably because you're betting on a mixture of experts approach. Mm-hmm. That's going to mean that people can include a composite of many different models, which ties into the third one, domain expertise models, right? Models that have specific data that are, maybe it's geospatial or a place that's near and dear to our heart at Opaque, proprietary data. You talked about financial services. It used to be the case that it is the recency of the data that drove the value on the data, where a lot of customers that we work with, big capital markets and exchanges, they would monetize their data by selling a subscription and give the customer, the client, the partner, the data set, and the value was in the subscription having the most recent data. That's not the case anymore. It's the historical data that's far more valuable now. So when you're talking about creating new models with new specialized data sets at Opaque, we're all about maintaining the sovereignty of that data within that AI workload. We've focused more on using it with RAG or maybe new ways of context. We just covered so much ground there around innovation. I want to drill into small language models and then we can go to RAG. But start off with your focus on small language models, and I assume that's my assumptions I just stated are correct, but tell us.
Yes, absolutely. So see, small language models, I want to be very clear that in some respects, the definition of small language models is almost in contrast because you got to distinguish them from large language models. But we should be very clear that these small language models, including the ones we produce, do take in large amounts of data. So really, the statement around small language models is an evolution of AI technology, where as a community, we have figured out how to pack a lot more knowledge, a lot more capability effectively into smaller and smaller number of parameters. We have figured out that high quality data trained well and efficiently with interesting architectures, you can do a lot with smaller number of parameters. So I think we should clarify the small doesn't mean it only takes in less data. That's number one, high quality data. Second is small language model is also reflected in our philosophy of small because it is fit for purpose. If I'm producing a model to do one thing really, really well, so let's take our time series model. The reason our time series models can run on a CPU and are less than 1 billion parameters is because we have a maniacal focus on time series forecasting. A very horizontal problem shows up in many, many, many domains. Let's get a model
very challenging
because
nobody does it very well.
Yeah, because there is like data with different characteristics, different seasonality, multiple channels, correlation. But by focusing on time series forecasting, if you have a model that's really, really good, we've been able to train it by taking a diversity of data, because the goal there is to teach the model, these are all the different ways in which time series data might show up. And when they show up this way, this is how you do forecasting. So when you point it to a new data set with very little samples, it's able to map, hey, this looks like that other data set that I was trained on. I'm going to use that to do forecasting. Now we will extend it. We will then do time series representation. But so small was first around parameters. Small is also related to fit for purpose, because by being fit for purpose, you can do a lot with small language models. So those are the two governing principles. And I think the third piece of this whole story is, look, we've seen now innovation on model architectures on a couple of dimensions. One is sort of mixture of experts. We actually released a mixture of experts model last October. We released a small mixture of experts model just to test the community. Now with DeepSeek, mixture of experts is everywhere. It's wonderful because we are doubling down on mixture of experts model, and the community support to run those models everywhere is starting to appear. And this is an example of, this is wonderful. We love the fact that DeepSeek went all in on mixture of experts, because it's going to drive the community to support that architecture in as many environments as possible. That's great, because our models are then going to run in as many environments as possible. The other angle to the architecture innovation is, we know that one of the reasons why inference costs go up a lot when you deploy models, one is obviously the size of the model. The other is context processing is quadratic, right? So longer contexts are harder to do because the transformer attention mechanism blows up the cost. There is a series of innovations starting to come up in the academic and technical community and starting to wrangle that down. And one example of that is these models called state space models in architectures. We actually partnered with academia, and our team actually released a set of models in this space. So all of them are geared towards bringing down size. And I think you made the point very well that bringing down size is not just because we want to bring down size, it increases accessibility. Every unit of reduction in the compute you need to run a model, I'm suddenly making the model more accessible to a set of developers who couldn't have touched that model until it got to that size. So that's the reason for this trend. It actually makes economic sense. And since we have an open strategy, it makes perfect sense in the context of that strategy.
Yeah, it feeds the ecosystem in a really novel and effective manner.
As you were talking about all the data that we haven't interacted with, I think people, we always talk about I guess geeky people talk about Amara's law, which says in the short term, we overestimate technology, in the long term, we underestimate it. And as you're listing all these data types, the one that we didn't touch on is just that data, that spatial data around us. So think about what's going on with Figure, the robots, and the Tesla robot, all that data for the large portion of the users of AI, we haven't even touched. And I like Jan LeCun, from the chief AI officer at Meta, always makes the point that AI isn't any smarter than a 4-year-old child, or I like to say, isn't any smarter than my dog, and I have a very smart dog. But we collect data that's easily collected through sensors, through IT systems. But there's going to be a whole wave of collecting spatial data so that we can have AI robots, that we have other data that we don't collect easily today to bring up around that Jetsons, I guess that dates me, the Jetsons vision of the future of all these automated things. So
we're scratching the surface.
We're scratching the surface. As big a deal as ChatGPT was when it came on the scene. It's just so early.
You ain't seen nothing yet. You ain't seen nothing yet. No, I mean, another example, we've all in the IT industry, and look at this example. The amount of data we collect with IT systems today, we manage them, we have SREs maintaining these systems. In many of our enterprises, there's this whole emerging area of FinOps, right? How do I optimize the cost, right? I'm running all these applications. Am I having wasted resources? There's a ton of data. And all of this data is also multimodal. At some level, you could say these are all textual data, but we all know event data looks different from log data, looks different from utilization data in CPUs and network cards. Models that make sense of all of these things help you run IT systems efficiently. We're scratching the surface on the art of the possible. And actually, this is why recently, something we didn't talk about in the conference, but I would, happy to share. We recognize that a lot of the ways we benchmark AI systems today isn't as domain specific. Everybody goes after the same general purpose, right? It's reasoning, it's AIME 2024 or code, or it's MMLU, empty bench, all the standard benchmarks. Okay, it makes sense. It's not bad, but it's like a baseline. In the IT domain, there is no reason to believe that a model, if you have a model that is empty bench 8.5, and Mark has a model that is empty bench 8, I have no reason to believe that Mark's model isn't a better base to go work with my IT data. Because empty bench looks at conversational AI. Why should I use that to go decide which model to use to do conversation? So in the world of IT, we actually released from IBM Research a benchmark called IT Bench. Actually, it's a meta benchmark, which is a set of scenarios, but you can use to create more scenarios to say, if I'm going to build agents that help me manage IT systems, optimize cost, troubleshoot, keep them up, what are the benchmarks that you want to evaluate what those agents are? Those benchmarks are not empty bench and MMLU and AIME 24. Why does a model that can solve math puzzles the right model to go manage IT system? I think that's another area where community innovation, which is something we didn't talk about, is going to be huge. Because there are going to be these developers out there or people who run IT systems who should be the ones creating open benchmarks so that when we now have agents and models getting released, they can say, is this a good model to build an agent for an SRE?
So this is a great point you're making about having domain specialized models. Let's take the IT bench, right? Or a car manufacturer. They have, let's say ServiceNow, an opaque customer, has a wealth of data specific to managing IT systems. That is their secret sauce. Right? That is what they are best in the world at, because they have the, let's say, global 3,000 companies, and they're running ServiceNow across all of their IT systems and managing their IT systems. Obviously, IBM is no small player in that space. But in this scenario, if I'm ServiceNow, I want to use my proprietary data with AI models, and I need to ensure that I retain data sovereignty. So ServiceNow is an opaque customer. We help them do that. This is going to increasingly be a point of challenge for companies. I had a conversation last year that's still ongoing with a performance car manufacturer that wants to evaluate using specifically Figure in their manufacturing. And their concern is the data exhaust that's coming off of using Figure in my manufacturing could potentially become a competitor that entirely disrupts the industry. And I've created this, and now it's eaten me up. So I know that talking with your team last night, this concern around AI, responsible AI, governance, sovereignty is one of your principal focus areas. Talk more about how IBM's approaching that.
Yeah, so I think this is a big topic. So maybe let's unpeel the onion, if you will, right? We're approaching this broad area of trust and responsible AI from a number of lenses. So one very sort of immediate practical lens is, as people even deploy today's AI systems, whether they use our models or other models, just this business of I need control over the prompts that go into the model. I need to know whether somebody's trying to jailbreak it, somebody's trying to send back. And then likewise, I need to make sure I have a way to check the output of the model. So just basic guardrails around model is a good starting one. That's why we released Granite Guardian models. They do that. They protect your model. It can be Granite or other models against a set of well-understood attack vectors. They check for obvious bad output, etc. And so that's, if you think of it, that's like basics, if you will, hygiene. The next level up from that is what enterprises care about now is, okay, before you even help me protect, help me just give a dashboard that says, what am I running, right? Just a view of what am I running? Because every enterprise out there is in a multi-model scenario. They are running multiple models, some their own, some they have fine-tuned, some they use through an API. Give me a pane of that. Give me basic governance where I know what happened, what use case is this model approved for? What data, if I fine-tune my model, what did I use to fine-tune my model? What benchmarks were run? When the model is running live in a production environment, basic monitoring to know how the model is performing. So you call that governance. That's a capability. That's, if you will, level up from hygiene. You now have to do that across your enterprise estate. Then you get to where you are going, which is, okay, so far I've been using models. I can monitor them. I know what models I'm using. Now tell me what data is going into the models, what data is coming out of the models, what is happening to the output of the models. Give me lineage of all of that is going on. And that's where I think the different levels of protection start to matter. There is data in an enterprise where classical securing, firewalling techniques, access control techniques will work. The model is just yet another component in there that works for a certain class of use cases. But as soon as you get to really, really sensitive data, then you get into, well, I want to make sure that the data going into the model, the actual inference of the model, the data coming out of the model only runs in certain secure environments where it can't be. That's where you get into the world that you were talking about, which is confidential computing, getting AI workloads to run in confidential computing environments. So I view this as a layer of capability. Not everything in an enterprise is going to need that, but it's not everything in the enterprise is going to simply need guardrails. You're going to need a spectrum of things, from basic guardrails around models to governance to lineage, just knowing what went in. I don't have to have everything in. I just need to know what went in, to the world that you're talking about. And I think the way enterprises are going to think about it is the way they think about data security and classification. I have different levels of data security and classification. I think the big challenge that we're all going to have to address is that is a little better understood in the structured world. In enterprises, we have dealt with structured data now for, I think the database, data warehouse industry is 3 decades old, maybe, roughly, right? So we have now 3 decades worth of learning on how to deal with access control and security in structured data. I think where Gen AI is going to challenge us is, A, the workload is different. So now, like with OPEC, you're looking to understand how do I run AI workloads in a secure environment, but the data is different. And I think a big journey is going to be, how do I do lineage tracking in unstructured data pipelines? When I take a document with an ACL and I break it apart and I pull out a figure and a chart and I chunk it into a vector database, am I going to have the ACLs go? What's going to happen?
Your hierarchical ACLs make no sense in an agentic world, right?
So these are the problems I think that we're going to solve. So one way to think about it is, there's going to be a set of data problems to solve. Understand maybe the concepts from structured data map over, the implementations don't map over because you have different data structures. And the other is the compute side, which is, okay, I understand what confidential computing for classical workloads are. What is confidential computing for AI? So the data and compute side are both going to be great areas for innovation and certainly great areas for the community as well.
I would talk to Jason from Anthropic, the CISO at Anthropic, on a previous podcast, and we were talking about confidential workloads for AI and the importance with agents. And after the podcast, I was doing some thinking, and if you apply combinatorial math to, let's say, the probability that an agent inadvertently leaks data, right? It's less than 1%. But just for the simplicity of math, so I can quickly do this, let's say we round up to 1%. There's a 1% probability that an agent is going to inadvertently leak some information that somebody isn't supposed to see.
Right.
When you apply that to 100 agents, you're at like 60% probability. When you apply it to 1,000 agents, you're at 99.9% probability that some data is going to be mismanaged, that's going to get passed around inadvertently. So the importance of this will become increasingly a bottleneck for companies to leverage their proprietary data.
Yes.
And to your point, at the beginning of the conversation, you mentioned DeepSeek. And the really exciting thing about DeepSeek, everybody went crazy over it. It's just another indication that models will commoditize, right? There'll be a commoditization of large language models. You'll start to see commoditizations of domain-specific small language models. And then there's going to be techniques that people will seek to use their proprietary data with both. And they'll need some kind of guarantees around that. We were talking at dinner last night about this a little bit. Like, hey, right now people are using RAG, but where does this go, right? It's probably not going to consistently be RAG. We're going to see innovation around how people use sensitive data with these small language model, mixture of experts, or, we're going to see innovation there. Mark, do you want? I should throw the question to you. Where do we go from here on using data with models?
So there's two parts. I want to double click on something Sriram says. We have 30 years of data warehousing experience. We also have 30 years of data, and 90% of that data is unstructured. 60% of that we only use one time. So all of a sudden, and the limiting factor was we didn't have enough data analysts to go out, analysts, is that how? Go after that data. So now we have these automated agents that can analyze that data. And we sort of know what went in, but we don't really know. So what we need to do is, if we want to data mine, Bloomberg was one of the first pioneers of their own, and what I call enterprise GPT. I think this is what we take something like Granite, we build enterprise GPT or enterprise GPTs with our data.
They used no sensitive data with that GPT, by the way. When they did the announcement, it was all like public data. It wasn't with any sensitive data, which was smart. They shouldn't have. But using Granite, to your point, with their sensitive, you can.
They have 100 years of financial data that is going to, but they might have had that in a format that we've not dealt with in 10 years, but all of a sudden you may uncover insights and all those things, and you really need a security posture for all that.
Absolutely. I mean, I think the conversation, I think, is coming back to, finally, with Gen AI agents and all of that, you are opening up unstructured data that has always been sitting around in an enterprise, but has never been capitalized as much as structured data.
And now you're like, oh my God, they have access to that.
I have access to that. I can make sense of it. I can chunk it. I can shred it.
Should they have access to that?
But then you're going to have to rethink on pipelines, access control, security, encryption, all of them. Which is amazing, because in some respects, we were waiting for a technology to unpack unstructured data. And I remember, I think even 20 years back, I would still go around giving talks saying 80% of the data in the enterprise is unstructured. But honestly, were we able to unlock it? No. Now, finally, we have the technology to unlock it. But to your point, we got to unlock it securely. We got to unlock it while preserving confidentiality. And that's going to require open vehicles, because if I can't trust my starting point, which goes back to the beginning of our conversation, if I can't have a trusted open base model on which then I build my private edifice by putting my data, I don't have anything to start with. And that needs to be something I trust, something I can stand by, something that gives me the right licensing base. And then I start to add my private data to it, build my own models, small, large, we'll get to all of those architectures. I think that's where the journey is going to be. And that's very exciting, because it taps into that 80% we have talked about for 2 decades and never managed to do anything. Finally, we'll start to touch that.
Yeah,
and unlock it.
Our partner, and we just announced investor, Accenture, calls it their trusted data foundation, which I think makes total sense. Like you have a foundation in which you take that unstructured data and you build a basis for trusted data that you can build your AI workloads on top of. Go back to state space models.
Right.
Explain this, because I have not read up on it. So educate us.
Wonderful. So state space models in some respects are asking the following question. Transformer architecture, which is the architecture that opened up the current, a revolution, they have this quadratic complexity, because what they are essentially trying to do is, for me to predict the next token, I'm going to allow you within a certain window to look at relationships to all past tokens. But that's like a combinatorially explosive thing to do. So yes, you learn all of these attention mechanisms, but that's why long context length is harder and harder, because you have this complexity of, before I can give the next token, I have to look at various connections amongst a window of past tokens before I can do that. Now, state space models are saying, is there a way to grapple that down? Go back to, if you will, classical recurrent neural networks. There were RNNs that existed before transformers. They had a nice little property that you could run them a lot more efficiently. The reason transformers took attention is they gave you better accuracy and performance. They were asking the question, is there a way to blend the best of both? So state space model, and so one of the things that's happening today is, can I get the accuracy in terms of the quality of the output of the transformer models, but balance that with the inference efficiency of RNNs or those kinds of recurrent neural networks? And state space models are trying to bridge this gap. That's basically what they are doing, without going into the math of it. And an even bigger innovation is, I don't have to necessarily say my entire model is a transformer model or my entire model is a state space model. I can mix and match. So what's the best way in which I have some layers that are transformers, because my model has lots of layers in it? Can I mix and match transformer layers with state space layers and get the best of breed of inference efficiency? What's the best way to do that? Now throw in your mixture of experts architecture, which says, look, the entire model doesn't have to be active to answer every question. Depending on the question, I only activate a portion of the network. So you see what's happening, right? All of them are going back to where we were starting with, which is, we know that not every question requires 500 billion parameters all to get activated. We're all trying to come at it in smart ways to say, for that question, how do I find, or whatever that query is, how do I find the most effective way for a model to respond to that question? By either slicing the network horizontally, which is what Extra of experts do, slicing it vertically, which is what all these different layers do, and then making some layers more efficient, etc., combining all of these things. And we're so early in this game that I wouldn't be surprised that between architecture innovations and platform innovations, I wouldn't be surprised if in the next 3-4 years, we see orders of magnitude reduction in the cost required to achieve the same task we are doing today. We have seen, I would say, at least one order of magnitude, maybe more, in the last 2 years. We went from 540 billion Google PaLM model to every model out there which is less than 5 billion can beat Google's PaLM model on every benchmark. So that's 2 orders of magnitude, maybe. I think another 2 orders of magnitude and more is quite possible. It's going to be a combination of model architecture and platform innovation. And that's really, really exciting to me. So think about how it opens up the ability to run AI in so many environments.
That's a great assessment. And thanks for the education. Mark, you were talking about, did you have lunch with Worley? Is that what you were?
Yeah. So I was in Austin.
Will Hurley.
William Hurley.
Which everybody knows as Worley.
Worley.
Yeah.
I was in Austin for, of all things, a newsletter conference. And
by the way, this is why I call Mark Minkle.
Yes.
Because he needed a cool name like Worley.
Cher was taken, Worley was taken, so now it's Minkle. But yeah, he was talking about, he has a quantum company, StrangeWorks, and the question always comes up: is quantum going to play a big role in AI? And I don't have a clear answer on that. What is, IBM definitely, I guess,
Well, who's actually running quantum workloads today? Actual applications, is anybody?
I think we have 70 systems deployed across the world.
Okay.
70 systems deployed across the world, a huge ecosystem using companies like the ones you mentioned, who provide software and services on top of quantum computing hardware.
So arguably, IBM would have the most production systems in deployment.
Upwards of 3 trillion quantum circuits running on our systems every year.
So I don't think that's arguably. I think that's a fact.
That's a fact. Yeah. So now, to your question on where we see in first breakthroughs, we think the first area is really going to be in fundamental science, materials discovery, chemistry problems. Because that's where naturally quantum physics came from trying to understand nature. Quantum computing is using quantum physics principles to do information processing and computing. The area where you're going to have the first impact is really in material science, where you were limited with classical computing to have to approximate nature because you just couldn't model nature faithfully. I mean, the number that I always remember from my colleagues in quantum physics is, let's take my favorite molecule, the caffeine molecule. The caffeine molecule cannot be perfectly modeled today with classical computers. I don't care how big, cannot be modeled. I think it requires a minimum of 160 qubits to even faithfully model a caffeine molecule.
Really? I did not know this.
Yes. So,
because it's a pretty simple molecule.
Relatively simple molecule. Yeah. And I remember it because I'm a coffee addict, and so I remember that number. So what that tells you is now, if I can actually model molecules way more accurately than classical, and combine classical and quantum, the impact on fundamental materials discovery, think better alloys, think carbon sequestration, think more green fertilizers, think maybe better coffee, I don't know. But right? Yeah. So I think, so that's going to be the real area of great impact. You asked about AI. So by the way, there is already a lot of AI being used in building quantum machines. There is AI used in error correction. There is AI used in the signaling mechanism and the electronics that we use. So there is a lot of AI used in building quantum. But I think your question was, is a quantum going to give us a new way to do data processing like the way AI is? Intuitively, it should. Because at its core, quantum can find patterns in data, quantum computing, that we know classical computing cannot. We just haven't yet figured out the class of problems where that is going to be true. So I would say, in order of likelihood, I think material science, optimization problems, and then I think data pattern analysis. That's sort of the order in which we see quantum computing really coming through. We're very, very excited. I mean, we've been out there. We publish a quantum roadmap. It's public. So you can actually go search the IBM quantum roadmap. You will see us declare how many qubits, how much error correction, how big a system we are expecting to release every year. And I believe our roadmap now runs, I think, up to 2029. So we've been very public about the progress that we see. We certainly think by the end of the decade, we are going to have applications, at least in the material space, that are clearly applications we couldn't have done with classical computing.
Great. That's super helpful. So it's another Worley's on the bleeding edge once again, doing exciting things in quantum computing.
I feel like AI is the most interesting thing. And then you start talking about the incredibly hard physics problem of holding these qubits in the right space. And you, like you mentioned, error correction. It is a Dan Brown novel times 10.
No, but look, I think these going to come together. Our view is that quantum isn't replacing classical. Quantum is going to complement classical computing. You're going to solve a new class of problems together. And in fact, we've talked publicly about classical computing, AI computing, and quantum computing coming together. They're going to help us solve problems that we just can't solve.
The question I get at Opaque, being the CEO of Opaque, because we provide encryption in use.
Right.
So data is encrypted. The owner of the data holds the encryption key. The algorithm owner or model owner holds the encryption key for the model, and they're able to process it all in an encrypted space in the silicon. People will frequently misunderstand and be like, oh, but quantum's going to break all encryption. But we already have quantum resistant encryption schemes that are techniques for it that are quantum safe. So that's not an issue.
And they're
but I get it often. Like somebody's like, yes, but what about this? It's like, well, first of all, that's like probably 10 years away. but we already have countermeasures for that.
What if Schrodinger's cat holds the key to the encryption? That was actually half of our breakfast conversation. Is as soon as you mention quantum, it's the quantum entanglement metaverse, probably exacerbated by the Marvel Doctor Strange world stuff.
But honestly, though, that quantum safe question is a fair question. The good part is we have the answer to it.
Yeah, we already have the answer.
And we have standards now, and we're very proud in IBM that actually every algorithm that our cryptologists invented is now part of the official NIST quantum safes. All of the algorithms came either from IBM or collaborated with IBM.
I think IBM's been a leader in this category for decades.
For decades. And so that's exciting. That's really, really exciting. And preparing for the future, as you said.
Well, this has been a terrific conversation. Thank you so much for taking the time with us today, Sriram. And Mark, I know that you've got to get back. I saw you looking at your watch.
Yes,
you got to get back because you have to talk.
We have AI talks and going on till 5 o'clock this afternoon. And I am the MC for, I believe, a third of them.
Yeah, so. And you've given me the coveted spot of the last session.
Yeah, actually, I'm actually really excited about the last session because we've gotten.
I'm your anchor to keep people at the event, right?
But it's a very much around security and AI, and we have sort of angles from multiple vendors, and we have a open source office from Intel participating. We've got companies like yours that is delivering solutions, and we've got a couple of folks who are deep into the research.
That's amazing. Okay, well, let's again, thanks everybody. Let's get Mark back to the conference, and thank you all for tuning in. Mark, that was great. You told Sriram that IBM's language model, or Granite, their whole family of language models, meets the Mark Hinkle definition of open source. What is the Mark Hinkle definition of open source?
You need to, as much as possible, understand how it was made to replicate as close to the results as possible. It is actually the code itself has to be a recognized open source model or open source license, as you would see from the open source initiative. You would have open source parameters. So these are the weights. When you see a model and it has 700 billion parameters, you want to know what those parameters are. And third, even though it's almost impossible to share petabytes of data, it's a data bill of materials so that you can understand what data it was trained on and know that data was, appropriately licensed and where it came from.
Great. So let's do key takeaways. We learned how small language models and state space models are helping to reduce costs and improve accessibility for enterprise AI architectures. I would argue that this is going to also improve the quality and performance of AI because it's going to make it easier for enterprises to use it with their proprietary data. Responsible AI governance, IBM's helping its customers view their systems much more transparently, just like you described, Mark, with the open source. And it was really nice to hear Sriram thinks the data and compute side are going to be big areas for AI innovation.
Yeah, I think that sums it up nicely.
If you like the show and want to learn more about how to use AI responsibly, check out our website at opaque.co. If you like the podcast, please subscribe and leave us a review wherever you get your podcasts. We really appreciate your feedback. We want to hear from you. This episode of AI Confidential was produced by Wolverton Media Solutions, Places Media, and Opaque. I guess it was also produced by the AI Enterprise too, Mark. I mean, you're involved. We should probably plug you there. And I'm Aaron Fulkerson. Thanks for tuning in.
And I'm Mark Hinkle. We'll see you next time. So keep in touch by subscribing to my newsletters at theaie.net.